Okay, now the next bit is how you would normally be taught this. Okay, now I had quite a lot of problems with this because all over the world basically people use the normal approximation, and it just seems absolutely pointless to me because it was invented because the binomial distribution is difficult to calculate. It has things called factorials, and factorials make computers explode. And so Excel has worked out a way to approximate factorials, which is how it does the binomial. But the point is that using Excel we can find the exact binomial answer. So if you can find the exact answer using the binomial, why would you use a normal approximation of it? Well, in the old days you did that because it was easier to calculate, but these days there is no difference in how hard or easy it is to calculate. So I made an executive decision or whatever and decided that you guys, because you understand how to use the binomial distribution, because you've done module 4, I think that this way is going to help you to understand it a lot better than this way. So this is the way that I'm putting it in here in case you ever go to do another stats course and they go, didn't you ever do the thingy properly? And you can say, well, we did it actually the better way, but she did tell us that there was this other way that isn't as good, or something like that. Okay, so many textbooks teach this test using a normal approximation. So unless, and in fact this only works if you've got large numbers too, whereas the one I've taught you works always. So unless NP or NP1 minus P is less than 10, it's reasonable to use a normal approximation. And some people say a cutoff of 5. Now that NP is quite a big number, because if your probability of defectives is say 0.05, in order to make that number equal to 10, you've got to have a sample of 200. Now a sample of 200 is jolly big if you're trying to do some things. And so in fact, the normal approximation doesn't work for an awful lot of things, and so it's not even a good thing to do. So that's why it's better to use the original. And what you would do is use the mean of that, standard deviation of that, and you would use this thing using norm dist. Do you remember norm dist? Well, you've got your sample proportion, you've got your sample something. Don't know what that is. Okay, and standard deviation. So that would have been that thing there, which comes to, oh okay, that's what we would expect it to be. So, because we're comparing the sample mean with the population mean, and so the population mean in this case is 0.04 times, no, can't remember. Anyway, so it's like that, but I'm not teaching you that, so you don't need to know. There you go.